Good morning, sixth grade. Hope you had a wonderful long weekend and enjoyed the nice weather. We're going to start today by going over the follow-up question. It says, a pet store owner, Byron, needs to determine how much to feed the animals. Byron knows he needs to order the same amount of bird food as hamster food. He needs 4 times as much dog food as bird food and needs half the amount of cat food as dog food. If Byron orders 600 packages of animal food, how much dog food does he buy? Let B represent the number of packages of bird food Byron purchased for the pet store. So let's organize this by making a chart. We have bird food. We have the birds, hamster, dogs, cats. So we call bird food B is the variable. We know hamsters and birds need the same amount of food, so I'm going to say that's also B. It says dog food needs 4 times as much. So I'm doing 4 times B, or we could say that's 4B. And cats need half the amount of cat food as dog food. So what's half of 4B? 2B. So I have a total, how many B's right now? 4 plus 2 is 6, 7, 8, 8B. But according to this problem, I want the total packages of food to be 600. So I'm thinking 8 times what is going to give me 600. Now, I could roll my 8s, I'll be here a while, or I could just do a division problem. 600 divided by 8, which gives me 75. So I'm multiplying by 75, or B is 75. So birds are going to have 75 packages of food. Hamsters are going to have 75 packages of food. And since B is 75, 4 times 75 gives me 300. And 2 times 75 gives me 150. And all together, this should add up to 600, and it does, because 75 plus 75 is 150, 150 plus 150 is 300, 300 plus 300 equals 600. So how many packages of food were purchased for each animal? 75 packages for birds, 75 for hamsters, 300 packages for dogs, 150 for cats, which is a total of 600 packages of food. All right, this is a review for our warm-up. I want to know what the area of the triangle is. And then if I have a rectangle that is a half a meter long and 3/8 of a meter wide, what is the area? I'll give you a minute to solve this. All right, let's start with the area of the triangle. So the area of the triangle is base times the height, which would give you the area of an entire rectangle, because the base and height are like the length and the width. But then we have to divide by 2 or take a half, because the triangle is only half of a rectangle. So 5 times 12 is 60. 60 divided by 2, or half of 60, is 30. So this triangle has an area of 30 units squared. How do I find the area of a rectangle? I'm multiplying the length times the width. I did it with fractions. 1/2 times 3/8 gives me 3/16 meters squared. Okay. Here is our challenge for today. It's called Areas of Irregular Figures. Determine the area of both figures on the coordinate plane and explain why you chose the method you used. Then write an expression that could be used to determine the area of the figure. Explain how each part of the expression corresponds to the situation. At this time, I would like you to go ahead and look at the figures 1 and 2, and write down things that you notice and wonder. All right, what did I notice and wonder about this? Notices. I noticed the first shape could be split into 2 shapes, a rectangle and a triangle. I noticed the second shape is a triangle, but it is difficult to find the base and height. Wonders. I wonder for figure 1 if I can find the area of the rectangle and the triangle. I wonder what strategy I can use to find the area for figure 2. How can I convert that shape to shapes I know and can work with? Again, here is the problem. Take a good look at it, and then I want you to go ahead and pause and solve the problem on paper. I will go back to it so you can see it. All right, so how are we gonna solve these 2 problems? So let's look at the notice that we saw in the first one. We can split this figure into 2 shapes, a rectangle and a triangle. If we know the area of the rectangle and the area of the triangle, we can put them together to find the area of the entire thing. So let's look. The length of the rectangle is 1, 2, 3, 4, 5, 6. And the width is 2. So we know the area is 12. And if we're writing this as an expression, we can do 6 times 2 plus, now we're going to do the triangle. This would be, I'm going to use R for rectangle, plus, now let's do the area of the triangle. The base is 2. The height is 1, 2, 3, 4. So we have 2 times 4. And then we have to take half of it or divide it by 2 to give me the area of the triangle. So 2 times 4 is 8. 8 divided by 2 is 4. So if we add these pieces together, 12 plus 4 gives me an area of 16 units squared. Okay, we have our expression and it's labeled. Now, the second one is more challenging. Why? We can't just split it as easily into rectangles and triangles. We could. There is a way to do it. You could make rectangles that you see in little triangles and add them up. But I wanted to show you another strategy, which is enclosing this in a rectangle. So basically, I'm drawing a rectangle around it. Just making it clearer. If I draw the rectangle and find the area of the rectangle, I can then subtract out these little pieces on the side, which are 3 triangles. So let's do it. How long is it? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So let's find the area of the entire rectangle. 7 times 6. Now I am going to subtract out the various pieces. Now I might want to find the area of each of the triangles individually and then subtract that out all together. So let's look here. I have a base of 1 and a height of 1, 2, 3, 4, 5. So the area of that triangle, 1 times 5 is 5. divided by 2 is 2.5 or 2.5. Okay? Hard to see, but I could put 2.5. All right, let's look at this bottom triangle. The base, 1, 2, 3. Height, 1, 2, 3, 4, 5, 6, 7. 3 times 7. Divided by 2. 3 times 7 is 21. 21 divided by 2 is 10.5. 10.5. Let's look at the area of the third triangle. Got 1, 2, 3 here. 1, 2, 3, 4, 5, 6. Just going to erase this just for the triangle. We knew that helped us find the area of the rectangle. 3 times 6 is 18. And 18 divided by 2 is 9. So now we're going to add up these pieces together, the areas of each of the triangles. So I have 2.5 plus 10.5 plus 9. See, what do I get? 2.5 plus 10.5 plus 9. So 2.5 plus 10.5 is 13, plus 9 is 22. So if I'm making an expression, this was the area of the rectangle, I'm just going to put R, minus 22, and 22 is the areas of the extra triangles. So if I do 42, 7 times 6 is 42, minus 22, I can tell you that the area of the triangle in the inside is 20 units squared. Okay? So, what did we learn today? Here are some reflections. To find the area of the first figure, I was able to decompose it into a rectangle and a triangle. I could find the area of the rectangle and triangle and then add the pieces together. To find the area of the second figure, I enclosed it in a rectangle. I found the area of the rectangle and subtracted out the triangles on each side to find the area of the irregular shape, which happened to be a triangle. Follow-up. The school is building a playground. Determine the number of feet needed to put a fence around the playground. And number 2, the school wants to lay padded tiles down for safety. Determine the area in square feet that needs to be covered by the tiles. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Monday. Please remember you have a group Google Meets meeting with either me or Mr. Lengthy this week. Have a great short week. Looking forward to talking to you in Google Meets or with you in this video next Monday. See you guys soon. Bye. Bucky, what did you think of math today? You have many thoughts. Your ears are telling us that you have an opinion.